Hi everyone, in this video tutorial we will learn how to simulate the billet impact in aluminum plate using Abaqus. We will go through all necessary steps to run our job successfully, and also we will see the result with different configuration and thicknesses. Let's get started. In our model we have all necessary parts. The first part the projectile, and the second part the plate, aluminum plate, with all necessary partitions, and also we have the projectile with all necessary partitions. Now, depending to your problem and your geometry of plate and projectile, you can use your own parts. Now let's go to assembly first and apply, and let's rotate the projectile in the right direction to the target plate. Axis of rotation, degree of rotation. Okay, now let's rotate in the other side. This part, click on, rotate to this axis. Let's add more. Okay, okay, done. Now let's move the billet in the right position in the contact with the plate. Select this point, starting point, go to this point, click OK, click done. Now we have the right assembly, all parts in the right position. Let's translate all assembly in the zero position. Click done before and select this point, go to the zero position. This is the coordinate of zero position. Now we have all model in the right position. Click OK. Now let's go to property module and let's use our material and in the model edit. We have density in the kilogram per meter cube. Also we have elastic property in the megapascal, also plastic property with Johnson-Cook hardening model with all necessary parameters, and also with sub option rate dependent with all necessary parameters for Johnson-Cook, and also we have Johnson-Cook damage model used in this material. Now let's go to create section aluminum, solid, homogeneous, continue, select material. Okay, we have just one material in our model, in our library material. Let's assign the section to parts. The first part is the projectile billet, and also to the plate, aluminum plate. Click done. Click OK. Now let's go to step and create dynamic explicit step, dynamic explicit with time equal to 8.5 seconds. Time unit is in the second. Click OK. Now Let's go to File Output, Edit, and use the status to see the failure of our plasticity damage. Status, some failure and plasticity model. Also, we can plot all necessary parameters. Let's select if we have any parameters we need to select and we need to get in the output ODB file. Let's go to failure. We don't need to select damage initiation criteria, hashing damage, maximum displacement. This for cohesive surface, cohesive surface, damage initiation through section points, damage initiation through all layers. I think we need to use this output. Click OK. Dismiss. Now let's go to interaction and create interaction property. Continue. Select mechanical, normal behavior with hard contact. Also, let's use tangential behavior with penalty. Friction coefficient equal to 0.3, for example, depending to your model and your assembly. Click OK. Let's go to create contact in the initial step. General contact. Let's select all with self with this property created. OK. Now let's go to create boundary condition and create the first boundary condition is the symmetry, anti-symmetry, and cluster equal in the initial step. Continue. Select these two faces and click OK. Use Ancaster. OK. Now to use the property of symmetry of our model, we need to use symmetry in the X direction and also the symmetry in the Y direction. Let's start with this side. Symmetry, anti-symmetry, and cluster. Click continue. Select these faces in this side, all faces. Click done. We have symmetry in the X direction. Click OK. Now let's go to the other side. Symmetry, anti-symmetry, cluster. Select all faces in this side. Second, third, fourth, fifth, sixth. Click done and select symmetry in the Z direction. In the Y direction, not Z direction. In the Y direction, because in the Y direction we have symmetry in this side and also symmetry in this side, the X direction in the Y direction. Now let's work with the impactor or billet. displacement rotation, select done, and we need to the translation just in the Z direction. Click OK. Now let's go to add velocity to the projectile in the initial step. Velocity, continue, and select the projectile impactor, continue, and in the Z direction we need to add our velocity or our impact speed depending to your initial velocity. Click OK. Now we have the direction of velocity in the reverse of Z direction, minus 1200 millimeter per second. Now let's go to mesh and let's mesh our model. Click on by number. Let's use 30 element in these sites. Click OK. Apply. OK. Let's use just 50 millimeter, 50 element or less. Let's use 10, and depending to your model you can use your mesh and size of mesh. For simplify the model, mesh, click yes. We don't need all this size of mesh in these parts. Let's go to 5, apply, delete previous mesh, OK, mesh, yes. Let's use less than this value, for example 2, apply, delete mesh, OK, mesh, yes. Now I think we have a great mesh for our model, but we need to use more mesh in this direction, in this element. Select all edges and add number by number. Well, for example 3 or 4, apply, OK, OK, mesh, yes. Now we have mesh in our model. Our plate, just the plate, but the projectile, not yet. Apply. Okay. Let's use the same method, the same steps to create final mesh in this side and use less mesh in this side. Let's add by number 25, for example. Apply. Okay. and let's use single. I okay, click done. Let's mesh our model, our projectile. Yes, we don't need this size in this zone. Let's go to this, apply, delete mesh. Okay, now should to reverse the direction, apply. Okay, yes. Let's remove the option in these edges. Okay, and let's mesh our model, our part. Let's minimize the mesh in this zone. Apply, delete previous mesh. Okay, mesh. Yes, we have problem in this edge. We have the same direction of, we have problem in this side, in this edge. Let's use the same 25, apply. Okay, delete previous mesh, mesh. Yes, we have good mesh in our part. Now, I think all things done in this model. Let's go to create job, create, continue. Okay, check our model, check. Before we go to the result, let's remove this boundary condition. We don't need this boundary condition. And after remove this boundary condition, let's run our job and see our result. We have completed job. Let's go to the result and let's go see the deformed plot animation. Let's remove unnecessary edges before and see the result. And let's plot and display the quarter or the wall model of our plate. This is our result of billet impact. And now let's plot some energy of our impact. Continue. Let's plot kinetic energy. This is our kinetic energy. Also plastic dissipation energy, strain energy. We have many types of energy. You can use total energy of output set plot. Let's use this energy and let's compare between two different thicknesses of plate of aluminum. The first one with 2.5 millimeter and the second one is with 10 millimeter. Let's take a look. Between this and this we have penetration, total penetration, and now we don't have total penetration. Let's display just the projectile. For example, part instance, bullet projectile in place and see the damage of projectile. You can also see the damage of our plate and make a comparison between two states and many different thicknesses in your project. Until now, I hope you enjoy with this video. Don't forget to subscribe in my YouTube channel and like this video. See you.